Okay, the next question I have here is taken from 1998, number 33. It's also a JAMB question. And you can see the question. It says the midpoint of the line, the midpoint of the segment of the line y equals to 4x plus 3, which lies between the x-axis and y-axis is. You can see we don't know the midpoint of this line. And another thing about this question is the midpoint. Normally, when we are to ask to calculate midpoint of a line, we are supposed to know 2 points on that line. That is the formula we derived in our previous session of this class. We said to calculate the midpoint of a line, you need to have at least 2 points on that line, so that you use the coordinate of the 2 points, which is x2 plus x1 divided by 2, then y2 plus y1 divided by 2. You will now get the coordinate of the midpoint, just like what we did in the previous example we just solved. After getting the midpoint of the locus, then we now use it to solve the equation of the line. But this time around, no point is given, but the equation of the line is given. So what are we going to do now? Okay, but the question says something here. It says this line lies between the x-axis and the y-axis. That means this line passes through the x-axis and the y-axis. So if it passes through those 2 points, I think that is where something good will help us in this question. Because if you recall our equation of a line, if you recall this formula is very important for general equation of a line, which is y equals to mx plus c. This equation is very important. So if you recall this equation, you will discover that when you have an equation in this form, which is how this question came, let me put the question down now, which is saying y is equals to 4x, y equals to 4x plus 3. So if you compare both of them, so if you do comparison of these two equation, general equation, and this one that the question is giving, you will see their gradient is 4. See, gradient is 4, and the y-intercept is 3. And you know what that means? That means on this y-axis, the line touches the y-axis at point 3. So we can get the intercept from this point now. And if you remember our intercept topic, when we did intercept on this topic, I gave you a condition. I say at y-intercept, let me put the statement down. I say at y-intercept, we said x is equals to 0. X is equals to 0. At y-intercept, x is equals to 0. So in this equation now, we already know that c is the y-intercept. So at y-intercept, x is 0. So if this line passes through the x-axis, see, it lies between the x-axis and the y-axis. That means coordinate of point on the x-axis. So we have a point now. So at y-axis, x is equals to 0 now. So coordinate. So we are going to have coordinate at y-axis now. Coordinate at y-axis is going to be, so x will be 0, y is going to be 3. So now you can see that we have a coordinate now. We can use this coordinate. So this is the coordinate we are going to use on the y-axis. So we need the coordinate on the x-axis so that we can use our normal formula for midpoint to get the midpoint of this line. So that's what we are going to do. Then the same thing you write for x-axis. Now at x-axis, or at x-intercept, this time around y is going to be 0. So x-intercept, y is going to be 0. So if y is 0 in this equation, if we put y as 0, what is going to be x? Let's solve for that. So if y is 0, so let's substitute it here and solve it for x. So we are going to have 0 is equals to 4x plus 3. Then solve for x. Whatever value you have for x will now be the coordinate at x-axis. So that is all. So without wasting time here, so to get x now, 3 need to go to the other side of the equation, and I'm going to have 4x. Let's put it in mass mode. I'm going to have 4x. 4x will now be equals to minus 3. When plus 3 crosses to the other side, it becomes minus. Then divide both sides by 4. We're going to have x is equals to minus 3 divided by 4. So this is it. Then you can now put your coordinate now. You can now say coordinates. The coordinate of, or the coordinate at x-axis. Coordinate at x-axis is, we have gotten this one now. So at x-axis, x is minus 3. Let's put it in mass mode. Minus 3 over 4. Then y is 0. So this is the coordinate at the x-axis. So with these two coordinates that are known now, we can get the midpoint. So we can now find the midpoint of this line. So what is the midpoint formula that we know? Midpoint. So midpoint will now be equals to, remember our midpoint formula, if we take this as our first point, x1 plus x2 divided by 2. So x1 is now 0, 0 plus minus 3 over 4, put it in bracket, minus 3 over 4, then divide everything by 2, divided by 2. So this is the x. Let me change this to x value. So this is the coordinate of x. Then for y now, we are going to have y is going to be equals to 4y, which is y1 plus y2 divided by 2, which is 3 plus 0 divided by 2. So if we solve these two, x and y, we need to solve these two, but whatever value we have for x and whatever value we have for y, that will be the midpoint of this question. And when we do it, we can test it with our GeoGebra to see if the answer is correct. That's one beauty of GeoGebra. When you are learning all these topics in maths, it's good you have GeoGebra software so that you can test your answer and understand the topic. You can see most of my solutions that I've done so far. You can see that I've always tried to use GeoGebra to check my answers, especially when you are practicing like this. When you are used to this system, you have no problem in understanding the topic. So x is now going to be equals to, so this is going to 0 will go, 0 plus this will remain the same. So this is minus 3 over 4 divided by 2. Then we are going to have, if you simplify this well, we are going to have minus 3 divided by 2 times 4. So that is what you are going to have here. You know 4 is denominator, so 4 is going to multiply 2. Take note of that. Then for the y now, y is going to be equals to 3 over 2. So finally now we can now say midpoint now. We can now say midpoint. Midpoint will now be equals to, let's put it in text mode. Let me remove this. So midpoint will now be, equals to, so this is minus 3 over 8, then the other point is 3 over 4. So don't forget, we need brackets here, open bracket, and we need to close bracket here, close bracket. So this is the midpoint, minus 3 over 8 for x, then 3 over 4 for y. You can put it in decimal. It depends on how the question comes. So let me put it in decimal. Depend on how the question comes. Okay, so midpoint will now be equals to So if I divide, let me do it here, 3 divided by 8, 3 divided 8, you are going to have, let me maintain two decimals, 0.38, 0.38, comma, that is minus 0.38. This is minus 3 over 8. Then 3 divided by 4, let me just remove 8 and put 4 there. 3 divided by 4 is 0.75. 0.75. So that is it. That is our answer to this question. The midpoint of this line is minus 3 over 8. It's minus 3 over 8, comma 3 over 4, or in decimal form is minus 0.38, comma 0.75. Let me test it and see if that is truly the answer using GeoGebra. So let's just see. So the equation we have says y equals to 4x plus 3. That is the equation. Let's see. Y equals to 4x plus 3. And remember, I told you that y-intercept is 3. You can see that the graph is giving me what we want. So the y-intercept is 3. So let's see, these are the 2 points we calculated the other time. So if I get my intercept, let me get my intercept. I want this line to intersect my y-axis. You can see it there. I want this line to intersect my x-axis. You can see it. You can see that we got the two intercepts correctly. You can see the y-intercept, we say 0, 3. You can see it. Y-intercept 0, 3. We got that. Then x-intercept, say at x-axis, which is in x-intercept. So at x-intercept now, we say minus 3 over 4, comma 0, and 3 over 4 is 0.75. You can see it, which is also correct here. Then if you find the midpoint of those lines, let's get the midpoint. This is the midpoint now. If I get the midpoint of this and this, you can see our two answers, which is in this. Let me see, something is missing here. This is minus 0.38. This is 1.5. This is 1.5. Let me see where we missed it. 1.5. Okay, so y is 3 over 2, not 4. You can see, so I can correct this here. 3 over 2. You can see the importance of checking your answers after getting your answer, which is very, very important. 1.5. You can see that nobody is perfect. You can actually make mistake after solving it correctly and still mistakenly put the wrong answer here. So with GeoGebra, you can see that's why when practicing, always check your answers if they are correct. And it's good to have this GeoGebra classic software. It's very important for all mathematics students. Try and have it. You can see how I just checked my answer and I discovered that I made mistake in putting my final answer, which is 1.5. So that is the midpoint, and which is correct. You can see 3 divided by 2 is actually 1.5. So 3 divided by 2, you see, it's 1.5. So that is 1998, number 33. Take note of that. Let's move to another question. Let's see how we go. So this one is taken from 1997, number 33. It's also a JAMB question, and this says the angle between the positive horizontal axis and a given line is 135 degrees. Remember what we mean by positive axis, positive horizontal axis. When we did this topic the other time, gradient of a line, I told you that gradient is also the line, is also the angle between the positive horizontal axis and the x-axis. That is also a line. That's also the gradient, the angle between that line that you need to get the gradient and the positive horizontal axis. Now they gave us the angle, so with this angle we can get our gradient. We say tan theta, so tan of this angle is the gradient of this line. So this is settled. So gradient is known already. Then I have to find the equation of the line if it passes through this point. So this is actually a simple question. It's a simple question. You are using this formula y minus y1. So this is the formula you are going to use, equals to put your gradient m, then bracket x minus x minus x1. So this is the formula you are going to use for this question. So we are not going to waste time on this. And the point this line passes through is 2, 3. So which is 2 for x. So x1 is 2 here, y1 is 3. But gradient, remember then we said tan theta is gradient. Let me get my tan theta here. Okay. We said tan theta is gradient. Okay. Get my trigonometry. Okay, this is trig. Okay. So tan theta is equals to m. This was what we proved the other time. So if tan theta is equals to m now, and tan theta is given as 135, so I have tan 135. Remember, is in degree. So 135 degree. Need my degree here. So 135 degree. So this. So it's going to be equals to minus 1. You can see it. So tan 135 degree is minus 1. So that is the gradient. So gradient is equals to minus 1. So that is all we need here. I can close this now. So if gradient is minus 1, then my equation of my line will now be y minus, so y1 is 3, which is equals to gradient is minus 1, then open bracket x minus, then x1 is 2, x minus 2. Then put the equation in the general equation form. So y minus 3 equals to, you open your bracket, which is minus x plus 2. Then take everything to the other side. So that is the end of the question. So if I take x first, I have x minus x become plus x, then plus y, then what next? Minus 3 minus 2 equals to 0. Plus 2 will become minus on the other side. So that is it. Equals to 0. Then what next? Okay, we add this and that is all. So you have x plus y minus 3 minus 2 is minus 5 equals to 0. So that is the solution to this question. Very short and easy. You can also test it if you wish. You can also test it. All I need to do, if I want to check if my answer is correct, I need to draw this line. This is my answer now. I need to plot this line. If I plot this line, I need to check if this line is going to pass through this point, and if the angle this line is going to make with the x-axis is going to be 135 degrees. Let's check it before we move on. Let me delete what I did last. Okay, so the answer we got, let me check it again. We got x plus y minus 5 equals to 0. So let's edit this one. X plus y minus 5 equals to 0. So you can see the line we just got. So this is the line. Okay, and remember the positive side is this, is the positive side. This is the positive x-axis, while this is the negative. It is the positive side we are taking as our angle. Take note of that. Then let's locate that point now. Let's locate the point, because the question said this line passes through this point. So find the equation of the line if it passes through this point. So let's locate point 2, 3 if it passes through that point. If it passes through the point, the first condition is satisfied. So point now, point 2, when x is 2, y is 3, you can see it's correct. You can see 2, 3 passes through this point. Then let's get this angle. Let's get the angle between this line and this axis. So I need this side, I don't need this one. Let me check if I can edit it here. I need one of 180. Oh, it's not changing. But you get what I mean. This side is let me just see if I can do it now. Okay, this is the point. Then this angle between this axis and this. Okay, still giving me on this side, but it's actually correct. So it's 135 because he gave us this angle is giving us 45 degrees. I know angle on a straight line is 180 degrees. So if you actually solve 180 minus 45, you're supposed to get 135. You're supposed to get 135. You can see it. 180 minus 45 is 135. So this angle is the positive one the question asks for, the angle between the line and the horizontal axis, and it passes through 2 and 3. You can actually see that we are okay in the question, so there's no problem with this. So the next example I have for us is taken from 1995 JAMB number 30, and this one says we have two perpendicular lines P and Q and R, and they intersect at 1, minus 1. So this intersection of two lines, so we'll have line PQ and line QR, and they meet at this point when x is 1, y is minus 1. It now says if the equation of PQ, see they gave equation of PQ, but they didn't give equation of QR. Now say find the equation of QR. See, that's what the question wants us to find. And remember when we did intersection of line, I told you that when you have two lines and you want to get point of intersection, solve the two lines simultaneously. So when you solve the two lines simultaneously, your two answers will be the point of intersection. So now that we have this, let's see what we are going to do so that we can get this equation. Okay, there's a condition here. The question says two perpendicular lines. That means the two lines are perpendicular. That means if PQ is perpendicular to QR, an equation of PQ is given, then the equation is a simple one. Why? Because perpendicular lines, there's a condition. It says the gradient of one multiplied by the gradient of the other line will be equal to minus 1. And that is all we need to do. So the next thing to do here is to make y the subject so that we can get the gradient of PQ. So if you make y the subject of this formula, x minus 2y plus 4 equals to 0. By making y subject, the other terms needs to go to the other side. Then x and 4 will go to the other side. It will now become minus 2y. Minus 2y equals to minus x minus 4. You know, plus will become minus when you cross over the equation sign. Then the next thing is divide both sides by minus 2. You are going to have y is equals to minus 2 divided by minus 1 is going to be plus 1, which is going to be 1 over 2x. Then minus 4 divided by 2 is going to be plus 2. So this is the equation when you make y the subject. So now that y is made subject, you now discover that let's take this line as the second line. Okay, let's take it as the first line. So m1, that means m1, that is the gradient of this line, is 1 divided by 2. That is gradient of this line now, PQ. So since we know that now, so you now say, therefore now gradient QR. So you now say gradient QR. Let's take gradient QR as m2. Gradient QR will now be equals to minus 1 divided by this gradient now, minus 1 divided by m1, which is m1. So this is the condition for perpendicular line. So if I want to get this gradient, how will I do that? So minus 1 divided by 1 over 2. So we have m2, I'll have my M2 will be equals to minus 1. Let's get this division symbol. So minus 1 divided by 1 over 2. Then therefore now my M2 is going to be equals to, you reverse 1 over 2, it will now be 2 times minus 1. So the answer is going to be minus 2. So this is the gradient. So now that the gradient is known, I can get the equation of QR. Since both of them meet at this point, that means QR also passes through 1 and minus 1. So that is all I need to do, and I need to use my equation, which is y minus y1. So y1 is minus 1 already, minus 1, then equals to x, so equals to m, which is my gradient now, equals to m, which is minus 2, then x minus x1, which is 1. So that is this. You open the bracket and put the equation in the general form, and that is all you need. So you now have y plus 1. So minus and minus is plus, which is equals to minus 2x, then minus 2 times minus 1 will give us plus 2. If I put it in the general form, I put my equation in the general form, I'm going to have plus 2x will go first, now be 2x plus y plus 1 minus 2, because plus 2 will become minus. Then finally I'm going to have 2x plus y minus 1 equal to 0. So there's equal to 0 here, don't forget, equal to 0. So that is all for this question. So the equation of QR is this. So that is it. So equation QR, let me put it in statement. So equation QR, so equation QR is, that is this. So that is the answer. I can also check if my answer is correct. All I need to do, I need to type this, my answer, then I will type this equation, then we are going to check if this equation will be perpendicular to this answer, and we are also going to check if both of them will meet at 1 and minus 1. So let me just demonstrate it, and that is all for this question. Delete this. Let's delete this. Okay, let me edit this. Let's see. Okay, so we have, let me check. I have 2x plus y minus 1 equal to 0. 2x plus y. Okay. 2x plus y minus 1 equal to 0. Okay, so that is it. You can see this is the answer we got. It passes through when x is 1, y is minus 1. You can see it. So let's type the second equation, let's see, which is x minus 2y plus 4 equals to 0. X minus 2y plus 4 equal to 0. Okay, so that is it. So if we check the angle between them, the angles between these two lines, you can see it's 90 degrees. But let me see, and the question says the intercept at 1 comma minus 1. Let's see, but they didn't intercept. This is where they're supposed to intercept. When x is 1, y is minus 1. They didn't intercept in this place, but they meet at 90 degrees. That means there's something wrong with the question. Let me see. Normally I told you that in intersecting lines, when you solve the two equations, you are supposed to get this answer. supposed to get this answer. But let me substitute, let me see. If I substitute this value into this, I'm supposed to get equal to 0. That's another way to know if your answer is correct in intersecting lines, because where the two lines meet, when you intercept the value of x and y into the equation, it's supposed to be equal to 0. So if I put 1, x is 1, let me try it here first. When x is 1, 2 times 1, you are going to get 2. Let me just do it here. 2 bracket 1, yes, then plus y is minus 1, so which is minus 1, then minus 1, supposed to be equal to 0. And so this equation we got gave 0. But let me try it in this one. Let me see. I'm looking at this question, there's mistake somewhere in the question, but the answer we got is correct. All the steps are correct. You don't need to be worried or afraid. So when x is 1, so I have 1 minus 2, then y is minus 1. Let me put it in bracket, minus 1, then plus 4. See, it's not giving us 0. See, x is 1, you have 1 minus 2, then y is minus 1. You can see x is giving us 7. So, and it's supposed to be 0. That means this question, there's mistake somewhere. Maybe where I copied it from, maybe they made mistake in the typing of the question. But all the steps, they are correct. You can see it, minus 1 times minus 2, this is 3. 3 plus and 1 minus 3 will give us 2. Let me see what is happening here. This is minus 2 times minus, okay, which is minus 2, which is plus 2. So 2 plus 1 is 3. 3 plus 4 is 7. You can see it. So we're supposed to have 0. So the question, even what they gave in the question, did not give 0. But don't worry, the question is, our solution is correct. This is just computer typing error, but the steps is correct. If not, we would have made this point supposed to meet here. So that is this solution. Let's do the last question I have for us, and that is the end of revision of questions on coordinate geometry. So this question is 2007 number 17. It says find the locus of point equidistant from two straight lines, y minus 5 equals 0, y minus 3 equals 0. You can see, and I told you that locus is just set of points that follow some particular rules. And this question says this locus, they are set of points that are equidistant from two straight lines. That means we have a line that have equal distance from two straight lines. So what this one means is these two lines must be parallel lines. That's what it means. Y minus 5 equal to 0, y minus 3 equal to 0. So if you plot this on a graph, you will see that the y-intercept is 5 and the y-intercept for this second equation is 3. So we are looking for the middle of 3 and 5. That's all what this question needs. So if you can get the middle, so this locus is going to pass through that middle. So those set of points of this locus will pass through that middle. That is the only condition whereby this locus will have the same distance, equidistance from this line and this line. So this question is very simple. All you just need to do in this question is use your midpoint. Just find the midpoint. So if you pick the two equations, which is y minus 5 equal to 0, then the next thing is y will be equals to 5. Then the next one is y minus 3 equal to 0. Then if you move on now, y will be equals to 3. Then find the midpoint of this. We already know that x is not in this question, so x is 0. So the x coordinate of x is already 0. So the answer for this will just be, now say y, that is the midpoint you need now. Just say midpoint. The midpoint will now be equals to 3 plus 5 divided by 2. That is all. And 3 plus 5 divided by 2, we are going to get our answer as that's 8 divided by 2, which is 4. So that is the answer. So since the answer is 4, y is not in this place. So you now say therefore now the equation of this. So you say find the point equidistant. So that therefore now the locus of point that's equidistant from these two lines is, so therefore the locus for the locus is, since y, the midpoint y is 4, now you now say y is equals to 4. Let's put it in mass mode. So y is equals to 4, then which will finally give us y minus 4 equals to 0. So this is the answer to this question. Y minus 4 equals to 0. That is the middle of these two lines. If I also check, we can see that it's correct. We can also check and be sure that we are correct before we go. So remember, the first line says y minus 5 equals 0. You can see the line passes through the y axis on point 5. Then y minus 3 equal to 0. You can see the line. So the middle, you see, you don't even need to solve. You can see that 4 is at the middle of 3 and 2. That's what we got. Then if I want to get this middle line now, all I just need to do, I need a parallel line. Now I told you that the perpendicular line is a parallel line. A parallel line of this that passes through this point. That's what we need. You can see it, y is equals to 4. You can see that is the answer, which is the same thing as y minus 4 equals to 0. So that's what we are talking about. So this question is not a difficult one. So this is all I have for you. The questions are so many. You can go through your past question, WAEC and JAMB. I've done so many examples all from the beginning of the topic. We have covered so many things, so you can revise these questions. They are just 10 short questions from this topic, from WAEC and JAMB past questions. You can see them, number 1, 2, 3. You can go through them, number 4, 5, 6, 7, 8, 9, and 10. So that is all I have for you. Go through them as revision question, as assignment question. You can revise them. Go through the videos from the beginning of coordinate geometry. Follow the class step by step. You see that all these questions, they are not difficult questions. So take note of these questions, revise them, then go to your past question, revise more questions on the topic, and go through the videos. Anyone you cannot solve, you see that it's not difficult. So that is all I have for us in my class on coordinate geometry. I hope you enjoyed today's class. We shall meet again another time.